So this is my attempt to explain how we worked out the genetic code. So here we have a test tube, and in here is going to go some cell extract. So you kind of like filter a cell. Ribosomes are small, so I've got ribosomes in there. There'll be some ATP present, and all the amino acids are present. Okay. However, in each of the tubes that we're going to make up, they're all going to have the things in black, but they're going to have one type of radioactive amino acid. There's 20 amino acids, so we'll have to set up 20 of these tubes. They will each differ by the amino acid that's radioactive. Okay, it doesn't mean that there isn't a non-radioactive version of the same amino acid, because all 20 amino acids are present. However, we're adding some extra amino acids of one type that are radioactive. And we're going to pop into here the sequence that we want to unravel. So I've gone for a simple one of just poly U. It's just U, 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 etc., etc., etc. It's just an easy one to kind of start with. So we pop that in, and translation will start to take place. And therefore, so I've just shown 5 tubes here. And in each of these 5 tubes, I've got a radioactive, this has got radioactive leucine in it, proline, methionine, phenylalanine, and serine. Okay, and so we leave these to do translation. Then we filter them, and we collect the filtrate. So we'll collect a residue in the filter. This is a nitrocellulose filter. You don't need to know it's nitrocellulose, but yeah, it's a nitrocellulose filter, and it's going to trap ribosomes. So the ribosomes stick to the filter. So in each of these, we're going to have ribosomes bonded onto the filter, and all the free amino acids are going to pass through. And I'm showing here that where it's yellow, it means it's radioactive. So in the one with radioactive leucine in it, the filtrate is radioactive. So leucine has just passed through the filter. It's not bonded onto a ribosome. Yeah, leucine has not been used in protein synthesis. Same for proline, methionine, and serine. However, in the phenylalanine tube, in the filter, we do have radioactivity. And I've done a very rough, messy sketch here of a ribosome bonded onto my mRNA. This will be poly U. I'm trying to show some tRNAs here. And this is going to happen in every single tube. We are going to get strings of phenylalanine in every single tube. However, only in tube 4 do we have radioactive phenylalanine as well. Therefore, some of the amino acids are going to be radioactive, and therefore that's going to be detected in the filter. So this method means that we can kind of replicate this, again, doing 20 experiments. All 20 amino acids need to be in 20 different tubes, and we need to pop in some mRNA code, and then see what comes out, and therefore we can work out what's coding for what. Yeah, so UUU codes for phenylalanine. Hopefully that's made a bit more sense. You don't need to be able to explain this experiment. It's just so that you're aware of it, and it's just like we're going to go like writing like the general gist about it.